Alright, so you guys, before we even started this section, you guys were doing things with the discriminant, right? And finding solutions for quadratic equations. Yeah, okay, so today we're gonna sort of do more with that, but you guys already know enough that you can, if the discriminant is positive, it has how many solutions? If it's zero, it has one, and if it's negative, it has exactly, so. If you turn to page 585 in your book, and you see the example 4, someone tell me what that question is telling us to do. Right?
Well, do you want me to read the,
Yep, just read the question. Or
like, where, like, above?
Just read the whole thing.
where it says physics application, just right below that.
A weight 1 foot above the ground and the move spring fast is shot up. Initial velocity of 35 feet per second. Will the bell ring at the top of the pole?
Alright, thank you. So, right below that, they give us that equation that says h equals, help if I have a pen, h equals negative 16 t squared, that's an awful squared, t squared, plus v t plus c. So first things first, what do any of those variables mean? Does anyone have a guess about what they could possibly mean with regards to what we're trying to find out about this
It's
problem?
really hard to read.
Okay,
Sorry.
nope, no problem. 16 t squared. That's not right. There.
How many steps?
Stefan?
Wouldn't the V be like the height we started with?
The what?
Like, wasn't V like the feet per second maybe?
Okay, so what are they talking about in the question? They're talking about when you say feet per second.
They say
Velocity.
Velocity. Okay, so V would stand for velocity, right?
Yeah.
Okay, so that's one of them. So what would H stand for?
Carnival C.
H is height.
H is height, okay. That's, H, height.
And is T time.
T is time.
C is carnival.
That's what I thought too, but sadly no, I wish it was. C stands for, no, not circumference, it stands for constant, and that just means the starting point of where it is. So for this problem, or that little picture that goes with it, what would our height be? Or if we're trying to find something?
Feet.
20? So why did you say 20, JC?
Because that's the highest limit.
That's how high it is in the picture, right? So our height that we're trying to find for our solution would hopefully be is 20. So what's our velocity? What do they tell us is our velocity?
35.
35? 35, that is very not clear. 35. All right, do they give us a specific time? No, they don't, because we're asked to find the time, right? Actually, no, we're not even asked to find that. We're just asked to use a discriminant, so I'll get back to that. So C is our constant. What do you guys think the constant would be? 1? Why?
This says 1 is for C.
Hmm?
1 is for C.
Oh yeah, that's what it says in there, but do you know why?
Because it goes up 1 way.
Right. Let's take a look at that question again. Where does it say that the weight starts out?
0. 5.
Hmm?
35.
That's our velocity, right?
Where does our what start?
Where does the weight start? Where does our problem say? Brighton?
1 foot above the ground.
1 foot. So that's what the constant is. So imagine me at a carnival game with the hammer and whatever. So here's our starting weight. It's 1 foot above the ground. This is not 1 foot. Don't judge me on that. So this is where it starts. So before anything even happens, it's 1 foot above the ground. Our velocity, so when I swing down the hammer, which probably wouldn't go very far because I'm a weakling, it goes up at 35 feet per second. So when I hit that weight up, it goes up at 35 feet per second. That's where we get our velocity. And then the height, that's the height at where the bell is. So I have to hit the weight hard enough. So when it goes up, hopefully 20 feet and rings the bell and I get a prize, woohoo. All right, so now we have a lot of numbers plugged in here, sorry, or a lot of variables. So do you think we could plug in all these values in for all their corresponding letters?
No.
No? Could we do the ones that we have? Okay. So what would this equation look like if we plug in all these numbers?
2 equals negative 16. Negative 16, 2, 2 plus 35 plus 1.
Okay, does everyone agree with this?
Would you have to leave the T after the 35?
This one? Yep, that's exactly right. Okay, so now we plugged in all of our numbers we found out, so this is looking pretty good so far, right? So this is basically a quadratic, or this is a quadratic that we've been doing. So if the problem is telling us to use a discriminant to find solutions, what would we do first in order to be able to use the discriminant? Trey?
Would we subtract 20 from both sides?
Sure. Minus 20, minus 20. There we go. So then we have 0 equals. And then what's 1 minus 20?
Negative 19.
Negative 19.
Thought you couldn't have a negative 16 squared.
Hmm?
I thought you couldn't have a negative 16 squared.
Why? Why can't we have negatives there?
The squared.
It didn't go down.
Hmm?
It didn't go down.
Didn't go down?
No, because the parabola would open down. It's
Right, because if this is negative, the parabola opens down, right? Right. Trey?
Can we add everything on that side to the other side?
Sure. So let's try that. So everything sound just changed, right?
Yeah, I just need to clarify more. We can do that, but
Yeah.
I just need to clarify where JC's coming from. I always encourage them,
Mhm.
especially for factoring. That was the reason. I encourage them to have the A value be positive. You can have a negative A value. It's okay. Let's just leave our A value negative. It's okay.
Okay.
Because we're not going to solve it by factoring. Okay, does that make sense? So we can have a negative A. And you're right, Malcolm, that means that, I think it was you, Malcolm, that means the parabola will open down.
Are we gonna get the same answer though?
Yes, we
Yeah.
will.
All right, so,
Good point, Jason.
all right, so this is basic quadratic form, right? So what do we always do when we have this and we're trying to find solutions?
Try to see
A, B, C. So what's our A?
negative 16.
Negative 16. B equals
35,
35. And C equals
negative 19.
negative 19. So problem is just telling us to use the discriminant to find solutions. So from here, or what's the,
Solutions. I'm sorry, I have to interject. We're not going to find solutions with the discriminant, we're going to find the number of solutions.
oh, okay. All right, so,
Wait, so are we just gonna get to where our discriminant is and then stop?
For now, yes. So what's the basic form of our discriminant?
What part of the quadratic formula, you don't need the whole thing. What he's asking is what part of the quadratic formula gives you the discriminant?
Before
B2
we.
minus 4AC.
No, it's the what?
Say
B
B.
squared
Minus 4 times 2 times.
minus 4AC, right? Is that what you were saying?
Yeah.
B squared minus 4AC, that's how we find the discriminant.
Right.
So we're taking part of the quadratic formula.
Alright, so we have A, B, and C, so we can plug all those numbers into A, B, C in there, right? So what would it look like?
35. Parentheses. 2. Minus 4. Negative 16. Times negative 19.
Okay, and then we can change this to add the opposite, right? So what's 35 squared?
1,225.
1,225. 25. Okay. Plus negative 4 times negative 16 is 64. And then times negative 19 is 1,216.
Negative.
Right, negative 1,216. Okay, so this is what we have so far. So what is 1,225 minus 1,216? 9. So that is our discriminant right there. That's positive 9, right? So since our discriminant's positive, that says there's how many solutions to this? 2. So since the discriminant is positive, the weight will reach a height of 20 feet and will ring the bell. Alright. So does everyone understand why that makes sense? That since our discriminant is positive, that we have 2 solutions? Yes, no, maybe so.
How come we never found out the time?
How come we never found the time? The reason is because the question is just asking us to find if that situation will reach the bell. So given the height of 20, the velocity of 35 feet per second, and the starting point of 1, given all those numbers, our discriminant says that we have 2 solutions, so that means that we will hit the bell and we'll get a prize because we're awesome. So the reason, what would happen if we use the quadratic formula to actually find our solutions? So what's our quadratic equation?
I think it's important that we understand what will we be solving for, which variable will we be solving for if we do the quadratic formula.
Okay.
It's important.
Okay, so,
I think that's the question that Malcolm was actually asking you.
okay, so this was our equation that we started out with, right? What's the only variable in there?
T.
T, and that stands for time. So if we use the quadratic formula for that equation, we'll be solving for time. With all those numbers, we'll be solving for the time it would take for the weight to get to 20 feet. Does that make sense?
Yes.
Okay, so let's plug that in because our quadratic equation is negative b plus or minus square root of, quick thing, we found the discriminant there, right?
Yes.
So should we have to put in b squared minus 4ac again? Nope, so we can just plug that in there. So there's that. since we already found it right above it, so then we have all over 2a. Alright. So we have some variables in there, so we can substitute those in. What's our b value? Right, 35. Plus or minus the square root of 9, all over, what's 2, or a, excuse me, negative 16, right. So then that, what's the square root of 9? 3. And 2 times negative 16 is
Negative 32.
32, right. So, we're at this point, we usually split these things up, right? So then we have negative 35 plus 3 over to negative 32. And our second one is negative 35 minus 3 over negative 32. What's negative 35 plus 3?
Negative
Negative
32.
32.
Negative 32 over negative 32, and that equals what? Equals 1. Negative 35 minus 3? 38, you're right, and then negative 32. What does that equal? On your calculator, what's that equal? One 1.19, okay, that's all right, in here, 1.19. All right, so these are our two solutions, and Emerson, did you give me 1.19? Okay, and you probably rounded that, right? Okay, so these are our two solutions for our quadratic equation, and that means that at these times, because we were solving for t, right, we were looking for time at which our weight would ring the bell and we would get a prize. So at 1 second and 1.19 seconds, that means that our quadratic hits 20 at both of those points. Hmm? No?
I just, can I come up and draw on the board what's really happening?
Yep.
Okay. When we set our equation equal to 0, what's 0? The time, the height, the velocity, what? I mean, we got that equation set equal to 0. What is 0 in the place of?
H.
The height, isn't it? Yeah. So when we solve this, and we said it's an upside down parabola, correct? So when you just solved it right now, remember when you find the solutions for a quadratic function, you're finding the, what's another name for the solution? So it's the z.
0.
The zeros of the function. In other words, we're just going to cross the what? X-axis. So we just found out that it's going to cross the x-axis here at ordered pair 1, 0. Isn't that what one of the solutions was 1? And the other one's going to cross, and I'm going to make this kind of wider than it needs to be, just to make my point here. The other one's going to cross where? 1.19. Did we round it to? 1 in the 1900s? 0. Okay? So we have this parabola that is opening down, right? So we just found that this is from the time it starts. We're saying when it gets up to here, this is its maximum. That's where the bell is, right? So this is how high up?
20.
20. Okay, how would we find the x value, which is the t value, which would tell us how long it takes to get up there? what would we have to do to find the x value of that point, which is the vertex, and we know that the vertex is on the thing called the axis of symmetry. Think hard, come on, do it, you can do it. How would we find the x value? Of here, this point, right here, of our vertex. How are we gonna find the x value? So in other words, we're figuring out how long did it take for once you hit the weight, for it to get up to reach that value. Stefan?
Want to like measure velocity per second, like when the speed went up and then both okay now.
We're looking for time. We're looking for time. We're looking for time. Isaac?
Like the 2015.
You don't have to, Rose, you have to work like that hard.
We just have to add the x's.
Add the x's, okay. Maybe we could do that and do what then with that? Divide by 2. Is that, okay, try it. Add the x's together. What x's, by the way? The zeros? Okay, add those x's together and divide by 2 and see what happens. What do you get? What is that?
1.009 rounded would be 1.10.
So rounded to be about 1 in 10 hundredths?
Yep.
Okay, huh, look at there, that's halfway between these two, isn't it? Yeah, good job. Now, that tells us it took how long for, once that weight was hit, to reach 20 feet? How long did it take?
1.10 seconds.
1.10 seconds, that's all. So when you solve it, we have to remember, what does that tell us about the graph? We have to put all these pieces together all the time. That's why I keep saying, we can't just move on to a new thing and forget about what we learned in the past. Okay? It is hard, it challenges you, doesn't it? Okay, but the important part I think that Mr. Allen wants you to get is really this. Are you going to require them to solve them, Mr. Conlon?
Nope.
Okay, what he really wants you to get is if you get a discriminant that tells you there will be real solutions, that tells you that the situation is possible. If you get a discriminant that's negative, are there any real solutions?
No.
No, so is it possible? No. So really, that's what it boils down to. Find the discriminant, which is going to tell you whether there are any real solutions or not. If there are real solutions, the situation is possible. If there are no real solutions, the situation is impossible. Okay? Okay, sorry that I had to interrupt, but I had to make sure we understood what we were looking for.
No problem. All right, so right below for example 4, there's a check it out thing, right? And it says, what if? So someone tell me what that one says. Shamarky, what does that say? So check it out right there.
Which one, the solving using methods?
Nope, the check it out right above that.
Oh,
Right there.
what if
Mm-hmm.
suppose the weight is shot straight up with an initial velocity of 20 feet per second? Delivering value, use a discriminant to explain your answer.
All right, thank you. So it's the same situation, right? But we have the same equation that they give us.
I think he means for all of you to be writing this down.
All right. So we said that H stood for height, Emerson.
So is the h the equation of the exact equation we're going to use after the whole sum?
No, it depends on what the situation is. For, this one is just dealing with that because it's the carnival game and it's, the weight is going up and down. But depending on what the situation is, that will determine what your H value or X's and Y's are. Okay, so you said H was height, right? And what's the height for this? What? 20, okay. What's the velocity? 20, right? That's our new one that they gave us. Time, they don't give us one, so it's just time, right? And then C is
Constant.
constant, and that is 1, right? So we have all of our variables, or most of them at least, so we can just plug all these in, right? So what would our new equation be?
0
Hmm?
0 equals
0 equals
negative 16 b squared plus 20b and minus 19.
minus 19, right? Notice that Stefan just put 0 in there right away because normally we would put 20 over there, but since we're gonna move it over anyway, he did that right away in his head, so. All right. Looks like a quadratic, so now if we're being asked to use the discriminant is what? Is what part of the quadratic formula? Mhm. All right. Oh, I forgot one thing. What do we always do before we start doing stuff? Someone said it was Stefan.
A, B, C.
A, B, and C, right. A equals
Negative
negative 16, B equals 20, and C equals
Negative 19.
negative 19. Thank you. So we have all of our variables identified. We just plug those in. So we have 20 squared. We can add the opposite, 4 times negative 16. What's 20 squared? 400. Plus, what was that big number before? Negative 4 times negative 16 times negative 19.
1,216.
1,215? 16. That's what I meant. All right, and what is 400 plus negative 1,216? Negative 816. And that is our discriminant, right? So, your discriminant is negative in this one, right? So that means there's how many solutions?
0.
0. And that means that, yeah, that means that this guy who's doing the carnival game is not gonna win a prize because he's weak. Right, so since the discriminant is negative, the weight will not reach the bell. Cameron?
So if the discriminant was 0, it'd still be positive.
Yes, because when the discriminant is 0, there's one solution, right? So even if there's just one, it's still possible. Good question. All right, so does everyone understand why these things are working, that when the discriminant is positive, you have 2 solutions, so that means if it is positive, that the situation is possible, if it's negative, it's not, so. Does anyone have any questions about what we just went through? Sounds means I did my job, but probably not. All right, so your assignment is on the board. You guys can get started on that. 3 word problems.